Chapter 4. Chapter 4 builds upon some of the concepts that we had studied in Chapter 3. If you recall, in Chapter 3, we did the one period model. And in a one period model, we had present value of started with a present value of 100, assuming we made an investment of 100. And we asked the question, what will be the value of this investment a year from now? And we applied this formula, future value equals present value times 1 plus r. And we worked out the logic as why that formula would be applied. So a $100 investment in year 0, in year 1 grows to 110, assuming that the interest rate is 10%. Similarly, we can take this formula and invert it to not now calculate future value, but calculate present value, assuming that future value is given. If you assume a future value of 110, again assuming an interest rate of 10%, then the present value is 100. So we can go back and forth applying these two basic formulas. Now what I want to do is transition a little bit and show how to use this same problem, solve the same problem using a financial calculator. And we will be using the Texas Instrument BA2 Plus as a recommended calculator, partly because I have this display over here that I can use to walk you through how to use the financial calculator. But if you prefer to use a different brand, that's okay with me too. So here is a replica of the Texas Instrument BA2 Plus. The on-off key is on the right-hand panel at the very top. I turn it on, and then I have to do a few things to prime the calculator. There are certain recommended steps to prime the calculator. If you don't do them, then you are likely to end up with the wrong answer, even if you make the correct entries into the calculator. So the first thing is that before you start any problem, you clear out any previously stored value. And you do that by clicking on the second key and then the clear work key at the very bottom over here, at the very bottom bottom left-hand corner. The second thing you do is you do a second and then click on the FV key, which is second FV. The FV key is on the third row from the top right hand, FV. So second FV, what it does is, if you can see it over here, right above the FV, there are the words CLR TVM, which means clear time value of money. Whatever has been previously calculated in the calculator, it clears it, because the calculator has an internal memory where it stores all previously calculated values. So we need to clear everything out every time we start a new problem. So this step of second clear work and second clear TVM, you need to do it every time that you prime every time you work a new problem. So in this problem setup, what do we have? On the first case, we had the following. We had present value as 100. But the calculator requires a certain convention. And the convention is to enter present value as a negative number. Then we had n, the number of periods, as 1. It was a one period model. And interest rate, in the calculator, the variable that enters interest rate for us is IY. IY is 10%. So going back over here now, I'm going to enter them, and I don't have to enter them in this sequence. I can enter them in any sequence I choose. So let's enter 100. I'm going to change the sign over here to negative, as you can see at the very bottom. And then I'm going to click the present value key. I'm going to click the present value key that's over here in the middle of the third row from the top. And my display says PV minus 100. Then I'm going to enter n as 1, so 1 and then n, and then 10 as my IY. And I'm going to compute, so CPT is the compute key, top row left-hand corner, compute, and I'm computing future value. So compute FV, and you can see it comes out as 110. Now if I want to repeat this thing for another problem, I will do second clear work. And I'm going to do second clear TVM. So everything has now been cleared out. I'm going to repeat it now for the present value calculation. So 110 is now my future value. Note I don't have to change the sign. N is still 1, IY is 10, and I'm going to compute present value. Present value calculates out to 100 with a negative sign. The negative sign, you can ignore the sign, but you need to remember that the calculator convention is to enter all present values as a negative number, even if present value is not a cash outflow. Okay, so that's a simple exercise on using the calculator to solve simple problems like this. There are a couple of things that I need to point out also in terms of priming the calculator. Number one is how many places after the decimal points you should have as default. My suggestion is to leave it as at least 4 places after the decimal point. And the way you do that is click the second key and the dot at the very last row, the format, second format. And your display would read DEC equals 4.0 because I've set it at 4.0. If I wanted to change it to 2 places after the decimal, I would do 2 and then the enter key at the very top row. If I want to change it back to 4, I would do 4 and enter at the very top row. Now that's set. That one does not need to be done every time. Once I set it, it remains that way until I change it again. The second thing I want to do is do a second, and I'll explain to you why I'm doing this later, but do this for the moment. Second and the payment key. Second and the PMT key, which is on the third row, second from the right. So second, and the display in this case reads END, which means I'm assuming all cash flows for the period occur at the end of the year. Now later on I can relax that assumption and see what implications it has, but for the moment our assumption is all cash flows occur at the end of the year. So it should read end. If it does not read end, then you do a second and enter, and it shifts it to BGN. That means it is assuming cash flows occur at the beginning of the period, but since I want it to be at the end of the period, I'll do again a second enter, and that changes it back to end. And it remains that way until I change it again. The next thing I want to do is second and then the IY key. Now over here my display says P/Y equals 1. I am assuming that there is one compounding per period. Later on we will see what that means. Can it be more than one compounding per period? And if it is, what are the adjustments we need to make? But we will assume the default case that the number of periods that we have, over here we have one period, so one period equals one compounding over that one period. So we will assume that the number of periods equal our number of compounding periods, and that's why it is set to 1. If it was any different, let's say it was compounded twice every year, I could easily change that to 2 and enter. That means now I'm compounding twice over every period. Compounding twice over every period would mean that I grow the cash flow for 6 months and then I grow it again for another 6 months, instead of growing it just in one step over that 1 year. But we will see more of that later. Our assumption is that this should always remain 1. And again, you set it that way and it remains until you change it back again. Okay, now to chapter 4. In chapter 4, we are now getting into different types of cash flow streams. And we are going to look at what happens to the different types of cash flow streams. So we make a simple one-period model a little bit more complicated and more realistic. So we are going to look at the following. We are going to look at how to value a stream of cash flows, and then the special cases if they are perpetuities or annuities, and what happens if the cash flows are growing, and how do we solve for other variables that is not either the present value or future value. So far we know how to calculate for present value and future value using the formulas or the calculator. What if we have to calculate the number of periods? We have to calculate the interest rate or something else. We will take a look at it. So in chapter 3, you remember that rule one was that only values at the same point in time can be compared or combined. I cannot compare present values to future values directly. I have to bring the future value to the present and then compare two present values, or I have to take the present value to the future and then compare the present values. So now going into a two-period case, what happens if I have two periods to maturity? So 0, 1, and 2. So we go back to our initial $100 cash flow, or $100 investment. We know that over that 1 year, when interest rate is 10%, that $100 would grow to 110. We just did that in the previous chapter as well as the previous slide. Now, what will be the value of that 2 years from today? In other words, what will be future value 2? Well, future value 2 would be 110, now growing at the rate of 10%. So now future value 2 would be 110 times 1 plus 0.1, which would be 121. So to get to future value 2, over here, the basics is that I did it in 2 steps. What if I wanted to do it in 1 step? Future value 2 would then be present value times 1 plus r to the power n. So present value is 100 times 1 plus 0.1 raised to the power 2. That would be 100 times 1.1 square, which would be 121. Alternatively, I could have used the financial calculator to do this thing. So I go over here, I do second, clear TVM, clear everything, make sure everything is blanked out. Now 100, change sign, is my present value. 10 is my IY. Interest rate is still 10%, but N has changed to 2. N is equal to 2. So now I'm going to compute future value. So that's 121. So I can easily use the financial calculator. And if I'm using the financial calculator, I want to make it a habit to still write out the variables every time. Present value is 100. So you can always go back and check what type of entries you made. Future value, that's what you have to calculate. IY is 10 and N is 2. Those were your input variables that you had into your financial calculator, and that gave you a future value of 121. So that's using the calculator for a 2-period model, and that we have captured over here in this formula, that future value at any period n is C, or the present value, times 1 plus r to that power n. And now we can also convert this into present value. So present value would be the cash flow at period n. That's the way I would rewrite this. I would rewrite this as Cn divided by 1 plus r to the power n. Or I would write this, instead of C, I would write this as the future value at period n divided by 1 plus r to the power n. So there are different ways in which these formulas can be written. Just be mindful of what these formulas are telling us and try to understand what these formulas are doing for us, and not treat the financial calculator as just a black box. So again, similar to what we have done before, suppose we plan to save $1,000 today and $1,000 at the end of each of the next 2 years. Now this is multiple cash flow. If we earn 10% interest on our savings, how much will we have in 3 years? Now looking at this, we have to convert this into financial variables. 10% is my IY, or my R, my interest rate. 3 is my N. And then I have cash flows of 1,000 and then 1,000 for the next 2 years. So I can put this into a timeline. So now I have a cash flow of 1,000, 1,000, and 1,000. How much will I have over here? Essentially, I'm being asked to calculate future value in period 3. One way in which we can do it is in a stepwise manner. Take the $1,000 and calculate its future value a year from now. So that would be 1,000 times 1.1, 1,100. I add this 1,100 to 1,000, right? So I get 2,100. Then I grow the 2,100 by one more year. So 2,100 times 1.1 is 2,310. To this 2,310, I add the $1,000, which is in year 2. So my year 2 cash flows, or year 2 values are 3,310, and then I grow 3,310 by one more year to 3,310 times 1.1 gives me 3,641. That's one way to do it. So we have a stream of cash flows, and we are calculating the future value. The other way to have done it is to take this 1,000, calculate the future value in year 3. This 1,000, calculate its future value in year 3. Take this 1,000, calculate its future value in year 3. So applying our model, the first cash flow, its value in year 3 would be 1,000 times 1 plus 0.1 raised to the power 3, because there are 1, 2, 3 periods between year 0 and year 3. This cash flow over here, its value in year 3 would be 1,000 times 1.1, same 1.1 before, but now for this cash flow we have only 1, 2 periods. So that would grow to 2, and then the final 1,000, this one over here, its value in year 3 would be 1,000 times 1.1. So I take this, this, and this, and I can calculate the present value or the future value of these 3 cash flows. So again, this is $1,000, its value in year 3. The second 1,000, its value in year 3. The third 1,000 and its value in year 3. So that gives us 3,641. Either way, we get the same answer. So I can do it, I could have done this again in a financial calculator. I could have done this in a financial calculator, so I could have clear everything, second, clear TVM, 1,000 minus is my present value, 3 is my N, 10 is my IY, compute future value. So that's the first 1,331. Then I can clear everything, 1,000, change sign is my present value, N is 2, 10 is IY, compute future value, my second future value, 1210, and then the third one similarly, and then I add them up. So I could have used the financial calculator instead of the formula. Either way would get me the same type of answer. So what we are using over here is how we denote these cash flows with time subscripts. This is a standard procedure that we use in time value of money. We take cash flows, represent them on a timeline, but also make sure that we denote their time suffixes. If I have a cash flow in a future period and I want to calculate the present value, we already learned these formulas on how to calculate present value of any future cash flows. And typically that's what we would be doing. Typically, most often, we will take cash flows in the future, convert them into their present values, and then do any kind of additions or comparisons depending upon the context of the problem. So here is an example. You've just graduated and need money to buy a new car. will lend you, your rich uncle will lend you the money so long as you agree to pay him back within 4 years. So you know the time period N is 4. You offer to pay him a rate of interest that he would otherwise get by putting money in a savings account. You think you would be able to pay him 5,000 in 1 year and then 8,000 each year for the next 3 years. So those are the 4 cash flows. 6% is the R. So how much you can borrow from him. So how much you can borrow from him, which would dictate to you how much you would pay for the car that you are buying. So we take all that information, this information, and the first thing we do is we convert that into a timeline. Over here it says first year, 5,000, and then 8,000 for each of the next 3 years. So first year, 5,000, and then 8,000 for each of the next 3 years. How much should you be willing to, how much should he be willing to give you? So one way to do this is to take the present value of each of these 3 cash flows. And if you add them up, that gives you 24,890. So all we are doing is we're applying this formula that present value is future cash flow in period N divided by 1 plus R to the power N, where N could be any number, 1, 2, 3, 4 in this case. So over here, the problem slightly changes because it says, suppose that gives you the money and then deposits your payment in the bank each year. How much will he have 4 years from now? So the problem over here, how much will he have 4 years from now, tells you that the problem is now a future value problem. So one of the ways in which we can do this is exactly like we did before, which is take the 5,000, grow it by 1 year, add these 2 up, take that, grow it by 1 year, add these 2 up, take this, grow it by 1 year, and then add these 2 up. So he would have 31,423 in his bank. Another way we could have done this is we could have taken the 24,890.65, which you had calculated over here, which is the amount that you could have borrowed, and taken that as the present value, and simply directly calculated the future value in year 4, which is to take 1 plus R and raise it to the power 4, and that will give you 31,423. Which tells you that there are multiple ways in which these time value of money problems can be solved. You have to figure out which way applies to which context of the problem and then approach it in that manner. Okay, here is another problem. Where it is? You just graduated, and to pay deposit on your rich aunt will lend you the money so long as you agree to pay her back within 6 months. She offers you a rate of interest that is comparable. And here are the rent, $70, $80, $90 for each of the next 4 months, $70 next month, $85 for each of the next 2 months, and then $90 for each of the next 4 months. Assuming 6% interest per year, how much money can you borrow? So here are your cash flows, $70 in month 1, $85 in month 2 and 3, and then $90 in month 4, 5, and 6. Well, the trick over here is to remember that the interest rate over here is given as per year, 6% yearly. But I have to, my time is monthly. So I have to take the yearly interest rate, divide that by 12 months, which would be 0.5. Which would be 0.5 monthly. And then I can apply the same process that we did before. Take each of these cash flows, get their present value, and from this, if I want, I can calculate the future value in period 6 as present value times 1 point R. So R is 0.5%. So in decimal, it will be 0.005, and I will raise this to the power 6. So I could do present value or future value, which would be 51611. So again, same thing. I can do it back and forth. 500, 1.005 raised to the power 6, 51611. My suggestion is to, if anytime you have to calculate future value for cash flows that are variable like this, the easiest thing is to calculate the present value of these cash flows and take the present value and convert that into future value. It's a two-step process, but it gets you into a regular pattern of doing things, which would help you minimize the errors that may possibly happen. Okay. So we have already talked about this. We have gone through. Now I want to look at a different type of cash flow that we call perpetuity, but we will cover that in the next lecture.